We are talking about vitamins in chapters 10 and 11, and we're going to start off here in chapter 10, which is dealing with the water-soluble vitamins, and also we have an overview that kicks this off. So the vitamins are called vitamins because they are vital to life. Vita means vital, and they are organic, which means that they are carbon-based. And also, what that is inferring is that they are made by living things. And so, living things make the vitamins, especially plants, but also sometimes animals, and then we eat the animals or plants and get those vitamins transferred to us as nutrients. Vitamins do not provide energy. Sometimes this can be confusing because some of them help your body use energy, especially the B vitamins. But you can think of it like this. If you think about your gasoline that you put in your car provides the energy. You burn the gasoline for energy. Now, you need other things in the car like spark plugs and carburetor and things like that in order to use and process the energy. Well, that's what the B vitamins are like. They're like the parts of the car that allow you to use the gasoline, the fuel line, and all that stuff. So you can't burn the energy without the B vitamins, but they themselves are not the gasoline. They themselves do not contain the energy. When we look at the vitamins, we can break them up into two major categories, the water-soluble vitamins and the fat-soluble vitamins. Water-soluble vitamins include the B vitamins, and there are many of those, and vitamin C. There's also another one, choline. And the fat-soluble vitamins are vitamins A, D, E, K, or ADEK, if you want to remember it using an acronym. Vitamins vary in their bioavailability. So bioavailability is the rate and extent that a nutrient is absorbed and used. So what is not the case is this graph over here. This almost never happens. So if you talk about a given vitamin, you say, okay, this vitamin is good for me. Well, what does that mean? Well, it doesn't mean that if the vitamin is good for you, that more of it always means that you have a better effect. That the more vitamin you take, the better it is for you. That is not the case. Typically, as you take a vitamin, the more of it you take for a while, then that's better for you. But after a certain while, you have diminishing returns. And you might reach a plateau where no matter how much more of the vitamin you take, it doesn't have an effect. Unfortunately, some vitamins and even other nutrients, the more you take is better for you up to a point, and then it kind of plateaus, and then it starts getting worse for you. So if you have too much of a vitamin, it might actually have harmful effects to you. And so therefore, for some of these vitamins, we have upper level intakes, which are going to be kind of a maximum amount of dosage that you should ever have in a day. Vitamins often have precursors, which are also known as provitamins, which are inactivated vitamins, and they have to be processed by the body to be activated. A good example of this is vitamin D. So when you eat vitamin D, it might be in the form of vitamin D2, it might be in the form of vitamin D3. You eat that and it's not actually activated yet. It has to go through your liver, and then only that, then it's converted into another molecule. It's still not completely activated. Then it has to go through your your kidneys. And then once it goes through the kidneys, you will have the activated form of vitamin D called calcitriol. So vitamins sometimes start off in an inactive form and have to be processed by the body first. The organic structure of vitamins means that they can be destroyed easily by cooking and improper storage. There are methods you can use to minimize nutrient losses, such as refrigerating fruits and vegetables, storing cut fruits and veggies in airtight wrappers or closed containers, refrigerating those. Use a microwave, steam, or simmering in small amounts of water, as opposed to using high temperatures for long cooking times. So there are some ways we can minimize nutrient loss, or vitamin loss. When we store vitamins, you have to keep in mind that, or solubility and storage, that water-soluble vitamins, which are B vitamins, vitamin C, also choline, circulate freely in the body and are excreted as urine. So what we're saying there is that they're not stored in the body for any longer than it takes to circulate through the bloodstream. Fat-soluble vitamins, A, D, E, and K, are actually stored in the body, in cells, and oftentimes in fat. So they stick around. So basically, your water-soluble vitamins, you have to take them every day, and they leave the body every day through the urine. Fat-soluble vitamins can get stored up in fat. You don't necessarily have to have them every day, although there are some that you do. Okay, when it comes to requirements, since you lose water-soluble vitamins every day through urine excretion, you need to take them frequently, typically every day or at least every 2 or 3 days. Fat-soluble vitamins you need in periodic doses, perhaps, it can be measured in weeks or even months, although we're going to see one of those particularly where there's an exception to that. So that is an overview of the vitamins, and we will have different sections on the B vitamins and vitamin C and the fat-soluble vitamins.